Okay, on to problem 6. So this one is sort of a follow-up to all of the projects and labs in the class and trying to get a sense of what you understand from those projects. So the first question is describe the process of inlining a function using an LLVM tool. What instruction types should you look for? What would you need to delete from the original code when you inline the function? So the first part, like what instruction types should you look for? If we want to inline a function, we would be looking for call inst. That would be the main thing that we would look for, just because that's what we would find in the code. So we would look for call insts, and we would want to replace those with with the actual body of the function. So call inst going to a function decal. And sort of writing out that a little bit nicer would be a good answer to the first part. What would you need to delete from the original code when you inline the function? Well, here we need to think about what happens when we call a function as compared to inlining that function. And so we would need to eliminate /fix parameter passing. And stack pushes /pops. So anything that's setting up variables to be passed into the function, we would need to get rid of and or put them in the right register so the code that we inlined would work properly. And then so that would be number one. The other thing we would need to do, return value handling, because we would have some amount of code that is there to take the value that we got from the function and put it into wherever it's supposed to be after the function call happened. We would have to fix up that code so that it just goes straight into the place that it's supposed to be in the inlined code. So those are the two things that I'm looking for you to think about here, is if we inlined a function, really just what type of LLVM construct are we looking for in our tool, and then how what are some of the finer details that we would have to handle, and that's just kind of understanding how code looks, what the code shape is. Part B. Could we inline functions at the source level using Clang? What is one advantage or disadvantage of inlining code at source level as compared to the IR level? So really the question here is, could we write a Clang tool instead of an LLVM tool that does this? And what would be the advantage or disadvantage of doing this? So yes, and we could look for call exprs instead of call insts. And then we could copy the source code for the function. And we could do the same sort of stuff to fix up the parameters so that they go into the right place, fix up the return value so it just it goes into the right variable, right? So we could copy it directly from there. This is actually how macros generally work in the preprocessor. So we could copy the source code for the function and fix parameters /ret values. Right, so there are a couple things we'd have to fix up again. So advantages and disadvantages. There are a couple things to think about here, right? It's really just, what could be worse, what could be better. And so in my opinion, this is probably a bad thing. The advantage here would be that it would improve the speed of the code. So advantage is, as usual, speed of code. You're sort of forcing the inlining. So if you really, really, really want that to be inlined, you know that the optimizer is not going to uninline it. It doesn't do that. So you know that you've made that choice for the compiler, which may be an advantage in certain cases. The main disadvantage is code readability, right? Because if we're doing this at the Clang level, now we're actually taking that source code, putting it into the other source code, and that might not be pleasant to read for a user. So it's generally not going to be a great idea to do this, just because you're going to be copying code into other code, and it's going to be hard to read then. So that's my take. That's the end of problem 6.